For Lab 5, I tested the law of conservation of momentum by rolling two pool balls together and observing the elastic collision. I used the momentum principle, which said that there's no change in momentum in an elastic collision, or that the initial momentum of the system is equal to the final momentum of the system. So I observed the motion of each ball, but I used the motion of the first one to predict the motion of the second ball. I did find that the pool balls mostly obeyed the momentum principle. There was a slight discrepancy between the calculated data and the actual data. This is due to friction. So to initialize this, I found that the mass of each pool ball was 0.16 kilograms and the diameter of each is 0.057 meters. The system includes the two pool balls, and I calculated the initial velocity of ball 1 and the velocity of ball 1 right after the collisions were found using data from Tracker and the formula, the change in position of x over the change in time, and the change in y over the change in time is equal to the velocity. So I'll run the Tracker model now. And you can see the first pool ball comes in with a constant velocity, collides with the pool ball at rest, and each one is sent in opposite directions at hopefully what's close to conserving momentum. And so more about the momentum principle. This states that there's no change in momentum for the system, or that the final momentum is equal to the initial momentum. And this was an elastic collision, so there was no change in internal energy. Also, no external force acted on the system. And the final velocity of ball 2 was calculated by finding the momentum of ball 1 initially, and this should be subtracting it from the final momentum of ball 1, and this is set equal to the momentum of ball 2, which I found to be 0.472 meters per second in the x direction and 0.322 meters per second in the y direction. So I created a Python model to model the motion of ball 2 with this initial velocity. I said that no net force acts on it because there's no, or I assumed an ideal system where there's no friction. I'll talk more about that later. But when I run the model, you see that the ball moves in the positive x and y directions as shown in the video, and I extracted the data from this computer model and compared it to the experimental data in green. And so this calculated data is above the experimental data, which is the experimental data is below the calculated data due to friction and a slight spin on the ball that took away from its translational kinetic energy. If I did account for friction, then the calculated data would line up much closer to the experimental data. So in conclusion, momentum was mostly conserved for this system. It is difficult to produce an ideal situation where no energy is lost to external forces and sources of energy. Some energy was lost to friction, but the pool balls were close to being a perfectly elastic collision. It has been a pleasure, as always, to produce this lab report. and have a nice day.